Welcome Math 136 students to the Module 05B Problem of the Week. And in this video we are going to solve a rational inequality. Now in this homework assignment you'll be asked to solve polynomial inequalities and rational inequalities. In my opinion, this is one of the more challenging inequalities you will be asked to solve. So let's start with moving one of the fractions over to the other side so that way we can compare it to 0. Anytime I'm solving these algebraically, that is my step. So if I don't have 0 on the other side of the inequality, I'm going to move the terms over so that they're all on the same side. So I'm going to subtract 4 over 2x minus 1 to both sides. And what I get is 1 over x minus 4 minus 4 over 2x minus 1, which is greater than 0. So now I'm comparing the left side to 0. Now what I need to do next is actually get a common denominator and combine these two fractions. So what I know is that the first fraction needs to be multiplied by 2x minus 1 over 2x minus 1. The second fraction needs to be multiplied by x minus 4 over x minus 4. In the numerator, I'm going to distribute 1 to both terms, so I get 2x minus 1 over 2x minus 1 times x minus 4. Next, I'm going to actually take this negative 4, so I'm going to take the negative and I'm going to assign it to that numerator of 4, and I'm going to multiply negative 4 to both terms here, so what I end up getting is negative 4x plus 16 over 2x minus 1 times x minus 4, which is greater than 0. So now that I have the common denominator, I'm going to combine the like terms in the numerator. So I have a 2x and a negative 4x, which combine to be negative 2x. I also have a negative 1 and a positive 16, which combine to be positive 15, still over 2x minus 1 times x minus 4, which is greater than 0. Now there's two attributes, critical attributes, that I absolutely need in order to solve this rational inequality. The first thing that I need is the x-intercept. Now the x-intercept comes from the 0 of the numerator. So you're going to take negative 2x plus 15 and set it equal to 0. And you're going to solve that equation, and what you get is x is equal to positive 15 over 2, or 7.5. Now the second thing you need, which I'll continue over to the right here, are the two vertical asymptotes. And those are your zeros of the denominator. So you're going to set 2x minus 1 equal to 0, solve that, and what you end up getting is x is equal to positive 1/2. Set x minus 4 equal to 0 and solve that, and what you end up getting is x is equal to positive 4. Now I'm going to draw a sketch of a coordinate plane so that way I can label everything that I have. This presents a visual for what I have. So what I know is that I have a vertical asymptote at positive 1/2, which I'll label here in a vertical dashed line. I have a vertical asymptote at positive 4, which I'll again label with a vertical dashed line. And then I also have an x-intercept at 7.5, or 15/2. And so this breaks up my graph into 4 intervals. I've got 1, 2, 3, and finally 4. And what I know is that in each interval, the graph is either going to be above the x-axis or below the x-axis, but never touching or crossing the x-axis, so it can't be both. And I know that because there are no x-intercepts except for 7.5, which is breaking up that last interval into intervals 3 and 4. Okay, and I know that this is what I'm looking for because I'm comparing this to 0, which is meaning I want to know where the outputs are positive, meaning above the x-axis. Now, what we need to do next is actually we need to test values in each interval. So I'm going to choose 0 for my first interval, 2 for my second interval, 5 for my third interval, and 10 for my last interval. And what I'm doing is I'm putting it into this function here. I'm putting it into the negative 2x plus 15 over 2x minus 1 times x minus 4. So that's what I'm substituting these values into. And what I end up getting here, and I'm doing the math for you, I end up getting 3.75, negative 1.83, 0.6, and negative 0.04. And I did round these values, but those are the values I get. Now again, what you're trying to do is compare to 0. Which of these values is greater than 0? Well, as you can see, 3.75 is greater than 0, zero point 0.6 is greater than 0, but negative 1.83 and negative 0.04 are not. So as a result, what this tells me is that my solutions are all in interval 1 and also interval 3. Now, interval 1 is going to be represented from negative infinity up to positive 1/2, put parentheses around both, union, and then the last interval, or interval 3, is going to be from 4 to 15 halves, put parentheses around both of those. So that's the solution to my rational inequality, okay? It's again all the intervals where my graph is above the x-axis, which happens to be from negative infinity to 1/2 and 4 to 15 halves. All right, guys, good luck.